Okay, in this video we're going to learn some big concepts in chapters 10.3 and 10.4. If you read through those textbook sections, there's a lot in there that we're not going to do, mainly because the calculator could do a lot of it and we'd just rather spend our time elsewhere. But all the big things that you need to know are going to be highlighted in this video. Now, the first thing I'm going to show you is more of a conceptual thing. So you're not going to have to do it this way. And what is it? It's to find the inverse of a matrix. So just know that after this example, there is an easier formula to find the inverse of a matrix, but I think it'll help you understand where that formula comes from if we kind of do it the long way the first time. So what is the inverse of a matrix? So let A be a square matrix of order n. So that would be, right here would be a square matrix of order 2, because it's a 2 by 2. And we're only going to find inverses of square matrices, and we're only going to find inverses by hand of 2 by 2 matrices. When we get to 3 by 3 matrices, those are going to be done with the calculator. And let I be an identity matrix. So that's, if it's a 2 by 2 identity matrix, it would look like that. If there exists a matrix A to the -1, so that symbol means the inverse of A, such that A times its inverse equals the identity matrix, then that is called the inverse. So, like I said, there's a way to do this with a calculator, but first, let's try to do it kind of from scratch. So that would be matrix A, and then let's make a inverse matrix, and we don't know what that is, so we're going to call it like A, B, C, D. Alright, and if this is really the inverse, by definition, it should equal the identity matrix. Okay, so that's what we're going to do here. Okay, I just paused the video real quick and rewrote it so I had more room. So I have a matrix times its inverse, and we're going to figure out what A, B, and C, and D are to find the entries of the matrix. And if they multiply together and give us the identity, then this would be the inverse of that matrix. So we're going to multiply these together. So we get this row times this column. So we get A times 1 plus C times 1. So that's going to be in that upper left-hand part of the column. Okay, then we're going to do row by column again. So row 1 times column 2. So we get B plus D is what 1, 1 times BD is. Alright, for row 2, column 1, we'll take row 2, multiply it by column 1. So we get 3A plus 4C. Okay, then we're going to do row 2 by column 2, and we get 3B plus 4D. Now, this should all equal this identity matrix in order for it to be a inverse. So then what you would do is you would take each entry in the same spot and set them equal. So like A plus C is equal to 1, and 3A plus 4C is equal to 0. Okay? Then we're going to solve this system. So I'm going to multiply everything in the top row by -3, and I get -3A minus 3C equals -3. Add these up, and I get 0 cancels out, C is equal to -3. Right? Then I could plug -3 back into the original, and I get A minus 3 is equal to 1, and I get A is 4. So right now, if this was our original matrix A, our inverse matrix is going to look something like this, where A, this first entry in the upper left-hand part of the matrix, is 4, and then C, this part down here, would be -3. And then you would solve the system of setting, B plus D equal to 0 and 3B plus 4D equal to 1. You would solve this system and get what these two entries are. And when you do that, when you do solve that system, you get that B is -1 and D is 1. So this is the inverse of matrix A. Alright, now I'm going to show you in the next video how to do this easier way, but I think it's important to see where the easier way, where that formula comes from.